Yeah, good evening, children. Good evening, online students.
Good evening.
Good evening.
Good evening.
Good evening. Good evening.
Good evening, ma'am.
Good evening. Yeah, so good evening, children. Good evening. Today's today's Friday, right? So Tuesday, I forgot we had to actually continue with this one, MCQs. But I started something else on Tuesday. I didn't realize I started and I think I later realized, so I didn't want to again leave that halfway and start this. I forgot about this one. Yeah. So these multiple choice questions were shared to you on WhatsApp during the Sunday's class, Sunday morning, last Sunday morning's class. I shared some images of multiple choice questions from this chapter, Congruent Triangles. That's what you see in the presentation here. Those questions only you see in the presentation here. All right, so let's discuss them. Yeah, so somebody's mic is enabled online. Please disable your mic. Okay, so we're discussing the answers to the multiple choice questions shared with you on WhatsApp during the Sunday session, last Sunday session. Yeah. So which of the following is not a criterion for congruence of triangles? C, option C, correct. Option C, SSA is not a valid congruence rule. SAS, two sides included angle. This is two angles included side. This is three sides. All valid congruence rules. SSA is not a valid congruence criterion. If AB is equal to QR and BC is equal to RP and CA is equal to PQ, which of these is right? Is the question. Which one? B. B. Online students, please participate. So B. Okay, so here from the class here, I get this option B. Let's check. Let's check if that's right. So as we have understood, you can take up any two equalities. Take up any two equalities. AB is equal to QR and AB BC. Okay, is equal to, here it's R, RP. So it's already in the correct order. So you can just take away this R. ABC, QRP. ABC congruent to QRP. Right? You might not see that here. You understand? This is how we understood. ABC, QRP. Right? This is how we understood. This is how we named the Kamlika, you didn't attend the class on Sunday, right? Okay. So ABC, QRP. Did I share the recording with you? Did you ask for the recording? I didn't share, huh? Okay, so ABC, QRP. Okay, this is the order in which we name the two triangles. Now you see, what are the options you see here? ABC, if it is ABC, it should be QRP. So this is not right. If it is ABC, then it has to be QRP. So this is wrong. Okay. And then what do we have here? CBA. CBA. So if it is CBA, then it should be PRQ, right? If it's CBA, then it should be PRQ. Yeah, CBA, PRQ. That's what we see here. This is correct. Let's just check the others also. This is correct. Then the third one is BAC. The third one, option C, is BAC. If it is BAC, then it should be what? If it's BAC, it should be RQP, correct? If it's BA, second vertex, first vertex, and then the third vertex, BAC, then it should be RQP. RQP. No, it is BAC and yeah, okay. Is it that? No, it's RPQ. Option C is RPQ. See that? This is the correct option. BAC congruent to RQP, but it is RPQ. The correct order is BAC congruent to RQP, but here we have RPQ, so this is wrong. And then if it is PQR, if it's PQR, it should be CAB. If it's PQR, it should be CAB. But PQR congruent to, it's given BCA. So that's also incorrect. So option B is the correct option. The correct option is option B. Yeah, so here in triangle ABC, AB is equal to AC, Angle B is 50 degrees. Then angle C is equal to 50 degrees. So this is by the isosceles triangle property. In a triangle, when two sides are equal, the angles opposite to them are also equal. Okay, so in this triangle ABC, these two sides are equal. The angle opposite to this side is this angle. The angle opposite to this side is this angle. So it's given that this side is equal to this side, which means the angle opposite to this side, this angle, is equal to the angle opposite to this side, this angle. So because these two sides are equal, these two angles are equal. So that means angle C is equal to 50 degrees. Angle C is 50 degrees. Correct? In triangle ABC, BC is equal to AB. BC is equal to AB. In triangle ABC, BC is equal to AB. Okay. So if these two sides are equal, children, then the angle opposite to this side is this angle. Opposite to this side is this angle. If these two sides are equal, then these two angles are equal. It's given that BC in triangle ABC, BC is equal to AB. BC is equal to AB. So opposite to the side BC is this angle, and opposite to AB is this angle. So if these two sides are equal, these two angles are also equal. So BC is equal to AB. Angle B is 80 degrees. This one is 80 degrees. Then angle A is equal to, how much is A? 50. Why? Because 180 minus 80, 100. And because this angle is equal to this angle, 100 by 2, 50 each. 100 by 2, 50. This is given to be 80. 180 minus 80 is 100 degrees. Now, since these two angles are equal, they'll share 100 degrees equally. So 100 by 2, 50 degrees. So this is 50, this is also 50. So angle A is equal to 50 degrees. In triangle PQR, angle R is equal to angle P. In triangle PQR, angle R is equal to angle P. These two angles are equal. So now, again, isosceles triangle property. When two angles are equal, the sides opposite them are also equal. Sides opposite to equal angles are equal. In a triangle, when two sides are equal, the angles opposite to them are equal. In a triangle, when two angles are equal, the sides opposite to those two equal angles are also equal. So if angle P is equal to angle R, the side opposite to angle P, this side, is equal to the side opposite to angle R, this side. So since angle P is equal to angle R, side QP is equal to side Q1. Now it's given that QR is 4, this is 4, so this is also 4. So they're equal. And PR is 5. PR is 5. Then the length of PQ is, so the length of PQ is 4 centimeters. Right? So we get PQ is 4 by the isosceles triangle property. Two angles are equal. So the sides opposite to them are also equal. So one of the equal sides is 4. So the other one is also 4. In the figure, write the correspondence if the triangles are congruent. So it's given that the triangles are congruent. Write the correspondence if the triangles are congruent. So let's just list out the equalities, children. Okay, so how do we start? See, this is not me. What we're writing now is not needed. You just have to select the correct order. But we'll also list the equalities with the help of which we can say that the two triangles are congruent. Okay, so what do you write? In first name the triangles. In triangle, when you're naming the triangles, any order is fine. Okay, so in triangle AOC and triangle BOD. BOD. Yeah, tell me the first equality. Now, when you look at it, what's the congruence rule? Just by looking at the information, online students, tell me the congruence rule.
SAS, Miss.
SAS.
Okay.
SAS. Two sides. Very good. Two sides and the included angle. SAS. See how to make out, because now you can see that this angle and this angle, they are not given to be equal, but they are equal because they're vertically opposite angles. Now we don't know if they measure 50 degrees, 60 degrees, 70 degrees. That we don't know, and we can't find that also. But we know they're equal. Whatever they measure, we know that they have equal measures because they're vertically opposite angles. And you see that for this angle, these are the two arms. This and this are the two arms. And for this angle, these are the two arms. And you can see that the arms of one triangle are equal to the respective arms of the other triangle, right? That's what makes SAS. SAS is one angle and the arms of that angle in one triangle equal to that angle and the arms of the angle in the other triangle. So it's SAS. Okay, so we'll write S first. I'll just number this 1 and 2. Okay, we'll write S first. So OA is equal to OB. Continue. OA is equal to OB. It's given, meaning it's marked. It's marked equal. Next, this is S. This is S. Angle 1 is equal to angle 2. Angle 1 is equal to angle 2. Now, this essay you don't have to write. I am writing, meaning here you should not write this. You must write the reason. In the bracket, you must write the reason. OA is equal to OB given. Okay. Angle 1 is equal to angle 2, vertically opposite angles. You must write the reason in the bracket. We are just writing to understand essay. Then again, you should write S. What is S? OC is equal to OB. Oh, OD. OC is equal to OD. Okay, given. Reason given. Reason given. Now, to name the triangles, see, you can also use one direction method. Okay, so you can also use the direction method. See that. So that also, once you've understood, this will be easy for you. Now, see here. Supposing you start from this side, A, O, and C. If you call this triangle AOC, now this AO is equal to BO here, no? See, like you're coming from this equal side, you're like saying hi to this side first. You're saying hi to this side, then the vertically opposite angle, this one, and then to this side OC. Just see the direction in which you're going. Okay, first you're saying hi to this side AO, then the vertically opposite angle, and then the other side OC. Do the same thing here also. Then you should start from B, right? So you'll start from B. You'll say hi to BO because this one is equal to this one. So you must say hi to BO. Then the vertically opposite angle here. Then to this side OD. So you can just use. You can just travel in the same direction. In the way you do in one triangle, go in the same way in the other triangle. So if you say AOC in this triangle, so you're starting like from this side, vertically opposite angle, and this side. So here it will be from this side, this vertically opposite angle, and this one. So if you say AOC, you must say BOD. BOD. AOC, BOD. Okay, so triangle AOC is congruent to triangle BOD by the SAS rule, SAS congruence rule. But This may not be, is it given? Yeah, it's given. So it's an option C, right? It's there in option C, AOC congruent to BOD. What are the other ways of writing it? Tell me, if I say triangle OCA, this is congruent to triangle ODB, correct. OCA, if you say OCA, then you must say ODB. Okay. If you say triangle CAO is congruent to triangle CAO, DBO, DBO, DBO. Okay. So here angles are not given to be equal. This one, okay, it's marked here. Even if it is not marked, you know that they are vertically opposite angles, so they're equal. No. Earlier, you know, I had a different broadcast list for online students and offline students. Then slowly what happened, students who come to the physical class, one or the other, they'll, you know, they'll say, today I'm taking an online session, share the link. So I had to share it individually to the other students. So now what I do, I have only one broadcast list. I put the link, so everybody will get the online link. So if you see that, that's why I don't share it before the class, because of this confusion. Otherwise, I can share the link as soon as I generate it. Supposing I do it in the afternoon, I can put the link. But sometimes it might be confusing. You know, you might think it's an online class. That's why I share it only when I start the meeting here. So when I was having that online, I had a group for online students separately. So I used to share it only with them. That I used to share it beforehand in the afternoon, sometime like that. Then slowly what happened, physical student, today, tomorrow exam. So today I'm online. So then to each, so if I receive some 3-4 students like that, I have to send it separately for them. So now I have only one group. So all of you will get the link. See the message. If I've messaged offline and online, there is, if I say online and offline, there is offline class. There is offline class. If you see the link, don't get confused. That link is for the online students. Follow the message. Offline and online. So there is offline, no? So that means you have to come to you can come to the center. But if you see a link after that, that is for the online students. So you don't have to get confused. Okay. Yeah, children. So vertically opposite angles are equal. Then this side is equal to this side marked. This side is equal to this side marked. So SAS congruence criterion, the two triangles are congruent, and this is the order, which is given in one of the options. This is the order given in one of the options. So C, option C is the correct option. So we know how to write, no? First, you should name the two triangles. Name the two triangles and list the equalities. List the equalities in the order of the rule you're going to use. If you're going to use SAS, list the equalities in that order. S, that is a pair of equal sides, then a pair of equal angles, and then a pair of equal sides in that order. In triangles ABC and PQR, okay. In triangles ABC and PQR, they should be of the same size almost. Okay, AB is equal to PQ, angle B is equal to angle Q, the two triangles will be congruent by SAS axiom if, okay, SAS. So you already have S here. You already have A here. This angle is equal to this angle. So what is that other information which you should have to show that these two triangles are equal by SAS? Yes, Blessing? BC equal to U? Same. Sana? Online students? What is that information we should have to show that the triangles are congruent by SAS?
BC is equal to QR.
BC is equal to QR, correct. So BC equal to QR. SAS, correct. So BC is equal to QR is the correct option. Okay, so in the figure, angle ABC is, okay, so we have to find the measure of angle ABC. ABC, okay, this one. You need to find the measure of this angle. Okay. Yes, children. I'll wait for 3 minutes. Angle ABC is 40 degrees. Are you sure? Yeah, online children. Measure of angle ABC. Here.
I'm 20 degrees.
20. Okay. We'll just wait for the others also. Anyone else online? 40. 40. Okay.
Anirudhan 20, ma'am.
Anirudhan 20. Okay. This is not, a restaurant where you're saying, give me idli or dosa. You should say 40. Okay. I'll let you. Fine. Let's recall the exterior angle property. Exterior angle property. So tell me. Now, F is an exterior angle of the triangle, right? F is an exterior angle. So F is equal to, the property is exterior angle is equal to the sum of the two interior opposite angles. I think 7th or 8th standard you have seen this. Exterior angle in a triangle is equal to the sum of the two interior opposite angles. So F is equal to
A plus C, ma'am.
A plus C. A plus C. See here, this is the exterior angle. This is its adjacent interior angle. This is the, see, there are two terms, adjacent interior angle, opposite interior opposite angle or opposite interior angle. Interior angles, with respect to the exterior angle, you can use the terms adjacent interior angle, opposite interior angle. All right. Now for this exterior angle F, B is the adjacent interior angle. Interior angle we understand. Triangle, three angles, three interior angles. The angles, the three angles inside the triangle. All right. Now for the exterior angle F, B is the adjacent interior angle. Leave that. Okay. What about A and C? For F, A and C, they are interior angles. Opposite interior angles for F. For the triangle, for the triangle, ABC are interior angles. For the triangle, A, B, and C are interior angles. Now, with respect to F, B is the adjacent interior angle. And the remaining two angles, A and C, for F are opposite interior angles. For F, they're opposite interior angles. So F is equal to the sum of the two interior opposite angles. Leave the adjacent angle. Leave that one. The remaining two angles, no, add that. So F is equal to A plus C. So now tell me what is D. Okay, tell me the adjacent interior angle for D. A. The adjacent interior angle for D is A. Leave that one. Which are the other two angles? B and C. So for D, B and C are the interior opposite angles. B plus C is equal to D. Now E is equal to? E is equal to? A plus B. Because for E, this is the adjacent interior angle. Leave that. These two, A plus B. So E is equal to A plus B. So this is the exterior angle property in a triangle. Now we can use that property here. Okay, so in this triangle, see, don't see this triangle. Take one by one. You need to use the isosceles triangle property. Can you see this triangle ADC? In this triangle ADC, this side is equal to this side, right? See, when you're using the isosceles triangle property, use it in one triangle, not in two different triangles. Isosceles triangle property should be applied in one triangle. Okay, so look at the triangle ADC. Which are the two equal angles? This one and this one. The angle opposite to this side is this angle. Don't get, it's not this whole angle. You should see within the triangle. You must see within the triangle. This is the triangle. ADC, this is the triangle. So which are the three angles of this triangle? This is one angle, this is one angle, this is one angle. Now you're looking only inside this triangle. You're looking at only these three angles. Now, when this side is equal to this side, the angle opposite to this side is this angle, and the angle opposite to this side is this angle. Don't see this part. These two sides are the sides of this triangle ADC. ADC. So consider only that triangle and see for the angles in that triangle. So the angle opposite to this side is this angle, opposite to this side is this angle. So since this side is equal to this side, this angle is equal to this angle. So if this is 40, this is 40. Now let's use the exterior angle property. So this is the exterior angle. For this triangle, see the side is produced. So this is the exterior angle. When a side of the triangle is produced, an exterior angle is formed. An exterior angle is formed when any side of the triangle is produced. So we produce CD. This is the exterior angle. Now this is equal for this one. This is the adjacent interior angle. Leave that. So this angle is equal to 40 plus 40. 80. So how much is this? This is the 80. Correct? This is 80. Now in this triangle ABD, now see, leave this triangle. Inside this triangle, see, look for the angles only in this triangle. In this triangle ABD, this side is equal to this side. So which are the three angles in this triangle? 1, 2, 3. These are the three angles. So opposite to this side is this angle, not this whole thing. Only inside this triangle you must see. So opposite to this side is this angle. And opposite to this side is this angle. Now we got this is 80. So this is also 80. Now 80 plus 80, 160. 180 minus 160, 20. So this angle is 20. So angle ABC is equal to 20 degrees. ABC is 20. See, if you understand the isosceles triangle property, then it's easy to find. We just use two properties. One is isosceles triangle property and the other is exterior angle property. You can do it even without using the exterior angle property. But you learn that you should try to use something often. Only then that also becomes easy for you. Like angle sum property in a triangle. We've been using it, I think, for 2 years. So now that's very simple for you, right? Using the angle sum property. So you should use the exterior angle property also. So as you keep using it, that also becomes easy. So this side, so doing it fast, this side is equal to this side. So opposite of this side is this angle, opposite of this side is this angle. So if this is 40, this is 40. Then by exterior, see, without using exterior angle property, so if this is 40, 40, 80, how much is this one? 100. If this is 100, how much is this one? Okay, if you, okay, okay, fine, this is 80. And then if these two sides are equal, right? So if this is 80, this is also 80. Then this is 20. So without using exterior angle property, you can find this angle 100. And then by using linear pair, you can find 80. But use exterior angle property. Understand, children? Yeah, please make a note of this. Isosceles triangle property. Isosceles triangle property. Finish writing, online students?
Yes, ma'am.
Okay.
Yes, ma'am.
All right. Is it visible? All of you? Okay. Now a figure is shown. You can see this figure here. You need to. A figure is shown here. Which of these figures is congruent to the given figure? Which of these figures is congruent to the given figure? B. Why? Why? So you're like just rotating it and answering. No, but if you have to write a reason, like if you have to, not this reason which you're saying, if you rotate it, it looks like that figure. Other than that, what reason can you give? No. Those rules will not apply to quadrilaterals. Yeah, they are only for triangles. Yeah. Online students, what's the answer? Which option?
Post the figure with B. Only one of them is seen and not the rest. And thus they are said to be congruent.
No, louder, Swati.
Ma'am, if you superimpose the question with option B, only the figure that is placed in the upper position gets visible and down is not visible, and so they are congruent.
Okay, so your option is B, right?
Yes, ma'am.
Okay, so maybe you're all trying to mean this, but I'll just put it this way. Maybe you will feel that that's what even we meant. Okay, so when you compare, when you compare the two figures, so you can see the sides, just check the sides, check on the sides 12, 10, 6, 11. 12, where is it 12 here? Can you see 12 here? See the sides, children, 12, 10, 6, 11, correct? Now congruent means what, children? Congruent means what? Equal in every aspect. Equal in every aspect. All sides should be equal, angles must be equal. So straight away, option A cannot be the right option because the sides measure different. This is 14, 9, 5, and 13. Correct? Okay, you all agree with me. Fine. Now look at option C. In option C, we have 11, 11, 5, and 9. 11, 11, 5, 9. So no, because in the given figure, we have 12, 11, 6, and 10. Correct? So option C is also not possible. Then look at the D option, 10, 11, 9, 5. This is 6. This is 6. So straight, see, which of these figures is congruent to the given figure? Congruency means equal in every aspect. Angles are equal, sides are equal. So when you check A, C, and D, straight away the sides don't match. All the sides are not equal. Maybe of the 4 sides, 3 sides are equal, but the 4th side, they're not equal. So then how can they be congruent? So ruled out. Now check this one. Now check this one. Now how to check this? So here you have 10, 12, 11, 6. 10, 12, 11, 6. But the order is important, no? So just look at this figure. Now where do we have 10 centimeters between the two right angles? So see here also between the two right angles we have 10 centimeters. See, there is no thumb rule for everything. It's very situational. For this, we are answering. See, to answer this question, we go ahead like this. A, C, and D straight away ruled out because the sides don't match. All the sides are not equal. Now, B, maybe the sides are equal, but how can you say that they are congruent? So it's like this. So now we don't learn about the congruence rules of quadrilaterals. We know only about triangles. So you just have to do it in a different way without using the criterion in a different way, but you should be sure that they are congruent. So how can you do that? So sides, they're all equal. Now, when you see where the sides are located, between the two right angles, we have 10 centimeters. Here also between the two right angles, we have 10 centimeters. Then between the right angle and 70 degrees is 12. Here also between the right angle and 70 is 12. You understand? And where is 11? Between 70 and 110. Between 70 and 110 is 7. Yeah, that also matches. And then where is 6 centimeters? Between 90 and 110. Between 90 and, yeah, everything is. So so when you place this one quadrilateral over the other, they will definitely coincide because we just checked everything. All the sides are equal, and the sides are also placed between the same two angles in both the quadrilaterals. So if 10 centimeters, it's between 90 degrees in one, it is there only in the other also. You understood what I compared? I'm not able to annotate because I've zoomed in. 12 is between 90 and 70. Here also 12 is between 90 and 70. 11 is between 70 and 110. Here also 11 is between 70 and 110. 6 is between 110 and 90. Here also 6 is between 110 and 90. 10 is between the two right angles. Here also 10 is between the two right angles. Now you will say, why you are spending so much time? That's what ACD is not possible. So it has to be B. Just tick B and go to the next one. I wanted to share this because supposing there was an option, none of these. Supposing this figure was not given and there was this option, none of these. Then you should know, right? You should know, meaning you should check if this and this are congruent or not. In that, if you had this option, none of these, then you will be forced to check these two, right? Then how will you check? This is how you check. See, now we have 4 options, A, B, C, D. A, B, C, not possible. So there is no other option. You have to select B. So it's okay even if you don't compare. But supposing the D option was none of these, then you will be forced to compare. No, A and C you will rule out because the sides are not matching. So A, C will say it's not possible, but B, the sides are equal. So you need to make sure that they are congruent by checking like this. So that's why we discussed that. So B is the correct option. So what am I trying to say? Now, supposing between the two 90 degrees, the side was 12 centimeters. They're not congruent. They're not congruent. Maybe the sides are all equal. You will have the same sides, 12, whatever there. You have the same sides. But in the given figure, between the two right angles is 10 centimeters. But in the option figure, if between the two right angles is 12 centimeters, then how will it coincide? When you place the 90 degree over the 90 degree, below it is 10 centimeters, above it is 12 centimeters. So they're not coinciding. So they're not congruent. Just for example, between the two 90 degrees, in the given figure, it is 10. But supposing here it is 12, between the two 90 degrees, it's 12. They're not congruent. Then you will say, if that changes, all the other values will change. I'm just trying to make you understand, that's all. Yes, if one value changes, the others also will change. But this is how you check is what I'm trying to convey. If between the two right angles is 10 in one figure and 12 in the other figure, they're not congruent. They're not congruent. So option B is the correct option. Because all the sides are equal, angles are equal, and between two angles, we have the same lengths everywhere. So 2 rectangles. Okay, so what the question says is a student draws 2 rectangles. Okay, a student, not, yeah, 2 rectangles a student draws. Okay. Okay, so there's a student who draws rectangles. Okay, so maybe he has drawn 2 rectangles. And looking at them, he makes these 2 statements. He makes these 2 statements. Rectangles, the rectangles which he has drawn, you know, the rectangles which he or she has drawn, based on the rectangles that person has drawn, he or she makes these 2 statements. What statements? Rectangles have the same perimeter. The rectangles drawn have the same perimeter. Rectangles have the same area. Now, this is the question for us. Which of the following statements is sufficient to conclude that the rectangles are congruent? So option A is option A. This is option A, option B, option C, option D. 1, 2 is this one. 1, 2. This is statement 1. This is statement 2. These are the options A, B, C, and D. This 1, 2 are these statements. Okay, so 1 alone is sufficient, but 2 alone is not sufficient. 1 alone is sufficient, meaning if they have the same perimeter, that's enough. But if they have the same area, that's not sufficient. What happened? Me? Option C. Okay. Okay, so what is given is, do we need both the statements to conclude that the rectangles are congruent, or is 1 alone enough? That's what we have to, they are the options. Now look at these rectangles. Supposing 10 and 4, 8 and 5. This is a rectangle. Rectangle, see, in 2 rectangles, angles are equal already. So angles you don't have to check, because in 2 rectangles, angles are 90 degrees. So we are only concerned about the sides. Okay. Now supposing the areas are equal. So you can see one rectangle with area. The first rectangle 10 into 4, 40 square units. The second rectangle 8 into 5, 40 square units. But are they congruent? No, because the sides are not equal. Congruent means exactly like the other. One is exactly like the other. No, they have the same area, but they're not identical. 10 fours are 40, 8 fives are 40. Correct, they have the same area, but they're not identical. Congruency is about being identical. They're not identical. Correct? Okay. Now let's see the perimeter. Now, supposing just take a value for the area. No, see, how did I draw this? I just took a value for area. Take some value for area, say 60. Say 60. It can be 12 5s are 60, or it can be 10 6s are 60, or 32s are 60. Just take some value, 60 square units. 60 square units for area. So draw a rectangle with area 60 square units. 12 5s are 60. Now take another, now tell me another product where you get 60. 32s are 15 4s are 60. So 15 4s are 15 4s are. Huh? 61 now. 60. Oh, yeah. Okay. Yeah. 60 into 1. Yeah. Okay. He's saying length is 60 and breadth is 1. Yeah. Okay. That also is fine. So these 2 rectangles have the same area. 12 5s are 60, 15 4s are 60. They have the same area. Correct? But they're not congruent because they're not identical. No. When you place one over the other, they'll not coincide exactly. Okay. So so what do we understand? When 2 rectangles have the same area, they need not be they may be, but they need not be. When 2 rectangles have the same area, they need not be congruent. Like if the area is 60 square units, It could be 10 6 are 60, 10 is the length, 6 is the breadth. It could be 12 5 are 60, 12 is the length, 5 is the breadth. Correct? Okay. So they need not be congruent if they have the same area. Now take some value for perimeter. Any value, say 50. Okay, perimeter is 50. So what is half of the perimeter? What is half of the perimeter? 25. Half of the perimeter is 25. So we'll take 25 as 10 and 15. Okay, so we'll make this 10 and 15. See, I'm taking a value for perimeter, children. I'm taking a value for perimeter. All right. I took what? 50. I divided by 2, 25. 25 is half of the perimeter, no? So that will be length and breadth. So 25. So I've taken the length as 15 and the breadth as 10. So what is 10 plus 15? 25. And 25 plus 25, 50 is the perimeter. Now take another rectangle. Half of the, okay, perimeter is 50. Half of it is 25. Tell me something plus 20, something which is 25. 12 and 13, 25. 12 and 13 or 20 and 5 is 25. Okay, so let's take another. Length is 20, breadth is 5. All right. We fixed the perimeter to be 50 units. Half of the perimeter is 25. So length 15, breadth 10. 15 plus 10, 25. And 25 plus 25, 50 is the perimeter. The second one also perimeter is 50, correct? So these two rectangles have the same perimeter. But are they congruent? No. So we took two triangles which had the same area. Not congruent. Did I say triangles? Okay. We took two rectangles which had the same area, but we understood that they are not congruent. Here we have taken two rectangles which have the same perimeter. They're not congruent. They have different lengths and breadths. How can they be congruent? So that means if you know that two rectangles have the same area, that's not enough to show that they are congruent. If you have two rectangles with the same perimeter, that's not enough to show that they are congruent. Are you getting me? When you have two rectangles with the same area, that is not sufficient, that is insufficient to show that the rectangles are congruent. When you have two rectangles with the same perimeter, that also is insufficient to say that they are congruent. But if you have both, this is the area, this is the perimeter. This is the area and this is the perimeter for both the figures. Then you can say that they are congruent. So you experiment with that. I've explained it. You experiment with that. So if you have an option like that, that's correct. Both 1 and 2 together are sufficient. Both 1 and 2 together are sufficient. But neither statement alone is sufficient. 1 and 2 together are sufficient. If you know the two rectangles have the same area and have the same perimeter, that is sufficient to say that they are congruent. But if you have only one of the two statements, I know that they have the same area, but perimeter, I don't know. Or if you have the statement, yeah, they have the same perimeters, but area, I'm not sure if they're equal. Then that information is not sufficient to say that the two rectangles are congruent. But if you have both the statements, yeah, these two rectangles have the same area and have the same perimeter, then you can definitely say that those two rectangles are congruent. All right. So you should remember this, and the option to the select panno. So the information is in two rectangles. When you know their areas and perimeters are the same, areas the same, perimeter is the same, then they are congruent. And the option irundha adu select pannalam. And the option irukku. Both 1 and 2 together are sufficient, but neither statement alone is sufficient. It's there. See, even if this is not there, it's okay. Both 1 and 2 together are sufficient. This also is the correct option. Not that this also should be given. That's just an extra thing. Both 1 and 2 together are sufficient is the correct option. And this is also correct, but neither statement alone is sufficient. It's true. All right, so C is the correct option. C is the correct option. Next one. So which of the following statements is correct? A triangle cannot have, yeah, this is your work. Yeah, do it. Please read and tell me the correct option.
A triangle can have all acute angles.
Correct. Sometimes, you know, of the options, whichever is most suitable, you should select that. Sometimes an option may not make, you know, like a complete sense. Sometimes an option might not make complete sense, but if you feel, yeah, this is also correct, you should select that because you have 4 options. And if it cannot be all of these, you have to select A, B, or C. You cannot leave without selecting anything. If you don't select anything, you will not get marks. Here in MCQs, you have to select an option. You have to select A, B, C, or D. If you say, meaning if you feel like there is something else also which is true and that is not here, and you don't select it because it doesn't, the options here don't match with what you have in your mind. You have something more appropriate in your mind, but that option is not here. So what do you think is, I'm not selecting anything. I have something, but that's not here. Okay, if you don't select, you will not get marks. That's all. You have to select A, B, C, or D. Yes or no? Because we don't have the option none of these. I'm not saying for this question. I'm saying in general. When you don't have the option none of these, you have to select one of A, B, C, or D. If all of these are illa, because you cannot have one obtuse angle and one right angle. One obtuse angle will be more than 90. Yeah, and one right angle is 90. So the sum will be more than 180, right? For 2 angles itself, the sum will be more than 180. If it is 190 degrees and this obtuse is 91 degrees, the sum of these 2 angles is 181. Then what about the third angle? This itself is not possible. Then 2 obtuse angles means suppose 91, 91. Again, why 91? Even 90.1 will go more than 180. Then what about the third angle? 2 angles itself, if they add up to 180. Yes. No, that's what I am explaining for. If if I'm saying in a triangle when 2 angles are obtuse, I'm saying in a triangle when 2 angles are obtuse, then the third angle is not possible, is what I'm saying. Okay. I'm saying like in a triangle. No, I'm not. I haven't still given the correct option. We are only talking that in a triangle, when we have 2, is it possible to have 2 right angles in a triangle? 2 obtuse angles? 1 obtuse and 1 right? Can we have 1 obtuse and 1 right? Online students? Okay, so we cannot, a triangle cannot have 2 right angles. It cannot have 2 obtuse angles. It cannot have 1 obtuse and 1 right also, but it can have all acute angles, right? Yeah. Now see the options. A triangle cannot have an obtuse angle and a right angle. A triangle cannot have 2 obtuse angles. A triangle can have all acute angles. All of these. Yes, why suddenly online students have gone silent? Online students, use the emoji, raise your hand. Haripranav, Laksha, Swati, Sadhna, Sabarna, Krishnapriya, Aniruddha, Anugraha. Roshni, are you there? Yeah. So a triangle cannot have an obtuse angle and a right angle. Is true. A triangle cannot have two obtuse angles. Is true. A triangle can have all acute angles. Is true. All of these is true. And the question is, which of the following statements is correct? All of these. Yeah. If the corresponding angles of two triangles are equal, if the corresponding angles of two triangles are equal, then they are always congruent. Is true, cannot be determined, false, none of these. Yeah. Did I see Hari Pranav? Yeah. Yeah, chalo. Yeah. If the corresponding false, huh? False. Cannot be determined. Okay. See, one thing is if the corresponding angles of two triangles are equal, then they are always congruent. One way you can say is that means AAA they're saying. You know that AAA is not a valid congruence rule. So false. Then they are always they are always congruent is false because AAA is not a valid congruence rule. And the other day we discussed that when you consider two equilateral triangles of different lengths, if you take an equilateral triangle of side 3 centimeters and another equilateral triangle of side 10 centimeters, 3 centimeters, 10 centimeters, both the equilateral triangles have the same measures of their interior angles, 60, 60, 60 in both the triangles. But are they identical? No, in one, the sides are 3 centimeters. In the other, the sides are 10 centimeters. One is small, the other is big. Or one is bigger than the other. So they are not congruent. If the corresponding angles of two triangles are equal, corresponding angles of two triangles are equal. So that means they're saying AAA. Angle 1 is equal to angle 2, angle 3 is equal to angle 4, angle 5 is equal to angle 6. Then they're always congruent. No, they may be congruent, but then see, when you take, two triangles and they're congruent, their angles will be equal. Their angles will be equal. But here they're asking if the angles are equal, will you say that they are congruent? No, if the angles are equal, we can't say because the exception is this one. Because when the two triangles are equilateral triangles, always the angle is 60 only. But that doesn't mean that the two equilateral triangles, one with side 3 centimeters and the other with side 10 centimeters are congruent, right? That's what it is. If the corresponding angles of two triangles are equal, then they are always congruent. Is false. They're always congruent. See that word there. They may be congruent. Then they're always congruent. No, it's false. Agree or disagree, children? Yes, Blessy, you have a question? Online students? They may be, yeah, they may be congruent. Yeah, they may be congruent. It's true. They may be congruent. அந்த மாதிரி என்ன சொல்றது confusing, there will be one perfect answer. Okay, so then they're always congruent is false. So you can consider this case. I'm just repeating. Sixty, 3, 3, 3. 60, 10, 10, 10. So you can see in these two triangles, the corresponding angles are equal. Angle A is equal to angle P. Angle Q is equal to angle R. Angle, BC, PQ. Okay, so angle A is equal to angle P, angle B is equal to Q, C is equal to R. The corresponding angles are equal. So then are these two triangles congruent? No. So they're always congruent as false. If an altitude of a triangle bisects the opposite side, then the triangle must be. Sorry? In this figure. It's given in this figure. In the figure. And you're saying right. In the figure, if an altitude of a triangle bisects the opposite side, then the triangle must be. This question is actually funny because they've given the triangle as an acute triangle. Okay, let me read it again to understand better. In the figure, if an altitude of a triangle bisects the opposite side, then the triangle must be. Actually, this is it's an isosceles triangle. In an isosceles triangle, the altitude will bisect the opposite side. We'll see that. But that's what. So earlier I made a statement. No, sometimes you should just choose the most appropriate option. You cannot say none of these because one of these is true. That's what I said. You cannot always find the perfect option. Sometimes you will have to select the most appropriate one. See, first thing is it's given in the figure. In this figure means this figure is not a right triangle, no? It's not an obtuse triangle. It is an acute triangle. Okay, in the figure, if an altitude of the triangle bisects the opposite side, then the triangle must be. So here I have to say it's acute only. That's how I understand. If in an acute triangle, it can bisect. In an acute triangle, the altitude can bisect the opposite side. Can bisect. Okay, let me tell you the property actually. When you take an isosceles triangle, in an isosceles triangle, an isosceles triangle can be an obtuse triangle also. An isosceles triangle can be obtuse. With these two sides equal. An isosceles triangle can be obtuse. It can be an obtuse triangle. These two sides are equal. Now the altitude from this vertex will bisect the opposite side. The altitude from this vertex meaning these two sides contain this angle, right? The altitude from that vertex will bisect the opposite side. These are the two sides these are the two equal sides. These two sides contain this angle or this vertex. If you draw an altitude from this vertex, it will bisect the opposite side. That means this one is equal to this one. This portion is equal to this portion. In an isosceles triangle, the altitude from the vertex, when we say vertex, it is the vertex, vertex contained by the two equal sides. When we say vertex, it is that, vertex which is contained by the equal sides. These two sides are equal. Isosceles triangle. These two sides are equal. So when we say vertex, because in a triangle, when you say vertex, there are three vertices. No, which vertex? In an isosceles triangle, the altitude from the vertex, correct? But when we say triangle and when we say vertex in a triangle, vertex is, we have three vertices, right, in a triangle. But when you say isosceles triangle and then you use the word vertex, vertex means we have three vertices. So you don't know which vertex are you talking about. When the term vertex is used with reference to an isosceles triangle, they are talking about that vertex which is contained by the equal sides, which is contained by the equal sides. So if this is the isosceles triangle, this side is equal to this side. These two sides contain this vertex. This only they're talking about. Vertex is this one. In an isosceles triangle, the altitude from the vertex bisects the opposite side. Bisects the opposite side meaning if this whole length is 12 centimeters, it is 6 here and 6 here. How we can prove by congruency? When you take up these two triangles, now let's name it A, B, C, and D. In triangle, now what is it given? It's an isosceles triangle. Okay, we are given it's an isosceles triangle. ABC is an isosceles triangle with AB equal to AC. And what is AD? It's the altitude from the vertex. Yes. All right, darling. Yeah, I'll share the recording with you. See. All right, it's an isosceles triangle with AB is equal to AC and AD is the altitude from the vertex A. Now we need to prove that BD is equal to DC. Now tell me, in triangle ABD and triangle ACD. ABD and ACD. Tell me, AB is equal to AC. AB of the first triangle is equal to AC of the second triangle. Then angle 1 is equal to angle 2. Can I say that? How can you say? Where is it given? Simply we cannot see. If I just started, you say yes. Who said angle 1 is equal to angle 2? Yeah. BD is equal to CD. Where is it given that BD is equal to CD?
AD is the common side.
AD is the common side. AD is the common side. Then
Angle C equals angle B by isosceles theorem.
But okay, very good. Nice that you came up with this. Okay, so now if supposing we write angle 1 is equal to angle 2, because Swati is right in saying that angle 1 is equal to angle 2 because it's an isosceles triangle, right? It's an isosceles triangle. This side is equal to this side. So that means the opposite of this side is this angle. Opposite of this side is this angle. See, when you see the triangle without the altitude, this is true. You have to, when these two sides are equal, see, when these two sides are equal, you must see the triangle in which we have these two equal sides. So for that, remove the altitude. See the triangle without the altitude. So you can see the triangle without the altitude. So these two sides are equal. That means this angle is equal to this angle. So Swati says angle 1 is equal to angle 2. Correct. Correct, because it's an isosceles triangle. These two sides are equal. So that means this angle is equal to this angle. Angle 1 is equal to angle 2. Okay, now supposing we write that angle 1 is equal to angle 2. What is this side? What is this side? What is this A? Okay, one more thing is are these two sides, do these two sides contain angle 1? See it, AB and AD. Do they contain angle 1? See, this is one side, this is the other side. Angle 1 should be here. What SSA is not a valid congruence rule. And I'm not saying SSA because I've written in that order. Leave this. You have mentioned two pair of equal sides and one pair of equal angles. So you have to use SAS. There's no choice because you have mentioned two pairs of equal sides and one pair of equal angles. Then what will it make? What rule will it make? SAS only. Because two sides, one angle. So SAS only it is. And if it should be SAS, it should be two sides and the included angle. Now, you have mentioned about AB and AD. AB and AD. AB and AD include this angle. Similarly, AC and AD in the other triangle, AC and AD. In the other triangle, AC and AD, AC and AD, they include this angle. So only if you know and write angle, this angle, that is if I mark this 3 and 4. If you write angle 3 is equal to 4, then it is SAS. Yeah, so we have written in triangle ABD and triangle ACD. We wrote AB equal to AC. That's because it's given isosceles triangle. Then AD is equal to AD common side, correct? And then angle 1 is equal to angle 2 because isosceles triangle property. Two sides are equal, so the angles opposite to them are equal. But this does not make a valid congruence rule because these two sides AB and AD, AB, see these two, I'm saying these two sides of one triangle, AB and AD, they contain this angle, but we have mentioned a different angle. And again, here AC and AD in the other triangle, AC and AD in the other triangle, they contain this angle, they include this angle. But we have mentioned some other angle. So though we have written two pairs of equal sides and one pair of equal angles, it does not make SAS. It makes SSA, two sides and some other angle. It doesn't make two sides and included angle. It makes two sides and some other angle, and that is not a valid congruence rule. SSA is not a valid congruence rule. So though we know angle 1 is equal to angle 2, we can't use it. Yeah, we want one more information. The triangles are congruent. Okay, which angle A is common? Which is common? Tell me. This whole angle, no? No, how? See, you know what? In this triangle, only this part of A is there. In the other triangle, this part of A is there. Which is common? In this triangle, only this part of A is there. In the other triangle, this one is there. How is it common?
Can we say by A is that angle D is perpendicular and it makes 90 degree?
Yeah, 90 degrees is correct. You can write 90 degrees. Correct. So what is it rule?
AAS, ma'am.
AAS. AAS is correct. But what's the other thing you can say? Any other rule can be used? AAS is correct, Swati. BD equal to? No, that's what we are proving. We're trying to prove that BD is equal to CD. No, there's an isosceles triangle and the altitude, that's the property. The altitude bisects the opposite side, but that's what we're proving. The altitude bisects the opposite side is what we're proving. We're trying to prove that BD is equal to DC. No. You can also use the RHS rule, right angle, hypotenuse, and side. You can all, so you can use the AAS rule or the RHS rule. Or the RHS rule. Yeah, well, if you write along with me, please write along with me. So any rule you can use. So this is the property. In an isosceles triangle, the altitude from the vertex bisects the opposite side. So from this, what is given? Isosceles triangle is given. The altitude from the vertex is given. Altitude is given. Altitude means it makes 90 degrees with the base. The altitude from the vertex, that's given. Bisects the opposite side, you have to prove. Bisects the opposite side, you'll have to prove. In an isosceles triangle, so we are given an isosceles triangle, the altitude from the vertex. The altitude from the vertex is given to you. Take the altitude from the vertex. Altitude means makes 90 degrees with the base. Altitude from the vertex bisects the opposite side. That's the result. Bisects the opposite side. So that's what we have to prove. So the question can be prove that in an isosceles triangle. Prove that in an isosceles triangle, the altitude from the vertex bisects the opposite side. So that means you will have to prove that it bisects the opposite side. The other things are given to you. Isosceles triangle given, altitude given. That means it makes 90 degrees with the base. That's given. It bisects the opposite side. So that means BD bisects, we understand, cuts into two equal halves. So BD is equal to CD. So we can use the RHS rule, right angle, because altitude. So we have 90 degrees. Hypotenuse, because isosceles triangle, no two sides are equal. So hypotenuse in both the triangles are equal. And any side. So AD is equal to AD, common side. We can use RHS or AAS. Sorry. So going back to this one. In the figure, if an altitude of a triangle bisects the opposite side, then the triangle must be an acute angle triangle. Now, for this situation, I can just tell you something. Now, if it's a right triangle, supposing it's a right triangle. Okay, the altitude from the vertex, this altitude from the vertex, it doesn't bisect the opposite side. See, in a right triangle, this altitude, no, it doesn't bisect the opposite side. If it's an obtuse triangle also, the altitude from this vertex, it'll fall outside the triangle. It'll meet the side produced. So it's not a right triangle, it's not an obtuse triangle, it's an acute triangle. In the figure, PM is the bisector of angle P. Okay, PM is the bisector of angle P. Angle is bisected. This PM, this line segment PM is the bisector of angle P. So this line segment divides this angle into two equal angles. And see, two things can be bisected. An angle can be bisected or a side, a line segment can be bisected. A line segment can be bisected. That means cut into two equal halves. Or an angle can be bisected, divided into two equal halves. So here, so if an angle or a side is bisected, somebody else is responsible for that, right? Something should bisect the angle or the side. So here, this angle P is bisected by this line segment PM. That's what is given. PM is the bisector of angle P. Something should cut the angle into two equal angles. So this line segment PM divides the angle. This line segment PM divides this angle P into two equal angles. PM is the bisector of angle P. So that means if this whole angle is 60 degrees, it becomes 30 here and 30 here. Because this PM is running between the two angles. Okay. And QM is perpendicular to, and PM is perpendicular to QR. PM perpendicular to QR. PM is perpendicular to QR. That means it makes 90 degrees here. Then the two triangles PQM and PRM, they are congruent by which rule? Is the question. Which rule? Online students, for quite some time it's been very silent. What's the rule? Haripranav, are you there? Aniruddhan?
Yes, ma'am.
Yeah. What's the rule? Okay. Aniruddhan, is this angle equal to this angle? Yeah, Aniruddhan, is this angle equal to this angle?
Yes, ma'am.
Okay, so let me call it 1 and 2. Then is this angle equal to this angle?
Yes, ma'am.
Let me call it 3 and 4. Now, tell me the line segment that is contained by angle 1 and angle 3. The line segment
PM,
that's
ma'am.
contained by 3?
Yeah.
Okay, very good. Now, also tell me the line segment contained by angle 2 and angle 4.
Ma'am, PM, ma'am.
Same thing, huh?
Yes, ma'am.
Okay. So now tell me, in triangle PQM and triangle PRM, you must say one angle of one triangle is equal to another angle of the second triangle. So can't we write angle 1 of the first triangle is equal to angle 2 of the second triangle? Why? Because
Yes,
it's
ma'am.
given P. Yeah, because PM bisects. It's given because
Ma'am,
PM
and-
is a bisector.
Ma'am, and also angle 3 and angle 4 are equal, and the PM is the common. So it will
Correct.
come as AS.
Very good, very good. Yeah. So PM is a side common to both the triangles. So PM of the first triangle is equal to PM of the second triangle because it's a common side. Common side. Then angle 3 of the first triangle. See here, angle 3, this is of the first triangle. It's very simple, children. An angle has 6 parts. One angle has 6 parts, 3 angles and 3 sides. You must write about those 3 angles or those 3 sides of one triangle equal to those 3 angles or those 3 sides of the other triangle. Nothing else you can take. If you take one angle of the first triangle, then you should write one angle of the second triangle. If you write one angle of the first triangle, sorry, if you write one side of the first triangle, then you must write one side of the second triangle. That's all. So angle 3 is equal to angle 4. You can see angle 3 is of the first triangle, 4 is of the second triangle, 1 is of the first triangle, 2 is of the second triangle. And PM is in both the triangles. Angle 1 is equal to angle 2. Reason is because PM bisects angle P. Because PM bisects angle P. So the two triangles are congruent by ASA, congruence criterion. Please make a note of this, children. Please write this. So if I say PMQ congruent to triangle, PMQ means
PMR, ma'am.
PMR. And the rule is ASA. So the answer is ASA. Finish writing, children. Consider the triangles made by two intersecting lines as shown. Yeah. So look at the figure. What additional information is required to prove that the triangles are congruent? Okay, what is that you have already? Let's write that first. In triangle POS and triangle ROQ, let's just write what we have already, children. I think we can see PO is equal to OQ. It's marked. PO is equal to OQ, correct? This side is equal to this side is marked. Or you can even write OP is equal to OQ. That's your choice. You can write OP also. PO, OP, both are the same. Okay. Correct. Let's number it. Okay. You're talking about this one, right? Yeah. Why? Angle 1 is equal to angle 2, vertically opposite angles. How much they measure, we don't know, but they're equal. Vertically opposite angles. Correct. OP is equal to OQ is given. Now tell me, what is that one other information you need?
SO equals OR.
SO is equal to OR. That will make which rule?
SAS.
SAS. Okay, but we'll just check the others also. If supposing SP is equal to QR is given, SP is equal to QR. What will happen? It will be two sides and some other angle. It will be two sides here. It will be, supposing this is given SP is equal to QR is given. It will be two sides and some other angle. Because these two sides contain this angle. And these two sides contain this angle. So that will not be useful. This information will not be useful. The last one. SP is equal to QR will not be useful. What about SO is equal to OR? Yeah, SO is equal to OR. Yeah, this will be useful. SO of this triangle is equal to OR of the second triangle. If this is given, then the two triangles are congruent by SAS congruence rule. Now, what about this one? OSP, this angle, and SOP, both of the same triangle. OSP and SOP. Okay, OSP, I'll show you again. OSP is this one. And SOP is this one. No, not useful. QOR, this angle is equal to OQP. OQP, which is that angle? OQP. Okay, OQP. So again, meaningless. So SO is equal. This should be given. This should be given. And then the triangles will be congruent by SAS rule. Correct, children? This one, there's a story we'll do it in the next class. It's time now. We'll just try to finish some simpler ones. Which of this cannot form a triangle? Wherever the angle sum property is more than 180 or less than 180. If you add and you get more than 180 or you add and get less than 180, triangle cannot be formed there. Option? Which of this can form a triangle? No, so option C. Correct. C. Option C. Correct. Then here. Okay, we'll just do these two and stop, children. We'll do 18, 19 and stop. Quickly tell me the 18th one. L is the bisector of angle A. See here, L, this one is the bisector of angle A. This is an angle. So L bisects this angle, which means this portion is equal to this portion. That's what is marked here. Can you see this angle and this angle? They're marked equal. Okay, so that's given. So in this triangle, this angle is equal to this angle in this triangle. We know that. And then you can also see that OA is the common side. If you take up this triangle and this triangle, you can see that OA is the common side. So then what are the information we have? 90 degrees. You can see there it's marked no 90. So what's the rule? AAS. Sorry?
Can we also use RHS?
Right angle hypotenuse and okay, which side will you say for S? Common side, huh?
Yes, ma'am.
No, which side? Which side will you say? OA is equal. OA is the hypotenuse. Which side? R right angle hypotenuse OA is equal to OA. Side.
OQ equals OP.
Okay. In the NCERT textbook, you know, it will be given that OP and OQ are equal perpendiculars. So there you would have taken OP is equal to OQ. Here it's not mentioned, so we cannot. In the NCERT book, it will be given that OP and OQ are equal perpendiculars to the arms of angle A. OP and OQ are equal perpendiculars. Equal perpendiculars meaning OP is equal to OQ, and they're also they're perpendicular. That is, OP is perpendicular to this arm, and OQ is perpendicular to this arm. Okay, let's just go back to that question in the textbook. So this is about an angle. This is about an angle. See here. This is angle A. This is angle A. Okay, and this line L bisects angle A. Okay, and from this point O, we have equal perpendiculars to the arms of the angle. From this point O, we have equal perpendiculars OP and OQ. Perpendiculars means 90 degrees and equal perpendiculars means OP is equal to OQ. Okay. Equal perpendiculars, equal meaning equal, OP is equal to OQ. Perpendiculars, 90 degrees. So yeah, then you can use RHS, right angle, and opposite to this right angle, OA, hypotenuse in both the triangles. Opposite to this one is OA, common hypotenuse. And then OP is equal to OQ. So then you can use RHS, the triangle congruent. Now because it's not given, right? It's not given. So here you should say this angle 1 is equal to angle 2. Then this angle 3 is equal to angle 4. And then OA is the common side. Angle 1 is equal to angle 2, 3 is equal to 4, OA is the common side. So AAS, the triangle, the congruent. So CPCT, you will get, name the triangles in the correct order, children. If I say AQO, it's congruent to. If I say AQO, it will be APO. So can you see that QO is equal to PO? QO, we can see that QO is equal to PO. And can you also see that AP is equal to AQ? Yeah, so if AP, this one is 4, AQ is also 4. AQ is also 4. In very simple words, children, let me finish it first. This is 5 and this 4. This is 3, right? Pythagoras theorem. This is 3, right? So if OP is 3, how much is OQ? OQ is equal to OP, right? So this is also 3. That's all. In this right triangle by Pythagoras theorem, this is 5, this is 4. So this one will be 3. If OP is 3, because by CPCT OP is equal to OQ. So if OP is 3, OQ is also 3, CPCT. So we have to find OQ, it is 3. It's 3. All right. It's time. All right, children. So that's it for today's session. Thank you so much. Online students can leave the class. Good night. Thank you, children.
Thank you, ma'am.
Yeah.